Okay guys, in this section 5-5, we're talking about bearings, and bearings is used in surveying and navigation, right? So a bearing measures the acute angle a path or line of sight makes with a fixed north-south line, okay? And so these are kind of examples of how you can get bearings, all right? So for example, and keep in mind, it is an acute angle a path or line of sight makes with a fixed north-south line. So the north-south line is your reference point for getting your bearing, right? Okay, so what you want to do is to get the bearing, you want to see what the acute angle is off of that north or south line. So like for example, if you're headed this direction in your boat or plane or whatever vehicle you've got going on here, then if you're heading this direction, you want to see what this acute angle is with the line of that side, the line of that direction, and the south line, right? And so if that angle is 35 degrees, okay, then the bearing is written with the north-south direction first, so it's south 35 degrees east, right? So in other words, you know that if you didn't have this drawing, if you just saw this bearing, south 35 degrees east, that's your bearing, then you know south is your reference line, and the direction you're traveling is 35 degrees east of that due south line. All right, so that's kind of what the bearing represents. So likewise here, okay, if you're traveling this direction, okay, then the acute angle would be to north, and if this is 80 degrees west of the north line, then your bearing would be north 80 degrees west. So that's how it's written out. So remember, the north-south in the bearing, the north-south is written first. The acute angle to the direction you're going comes next, and then the direction either east or west of that north-south reference line is written last. Okay, so the north-south comes first, the east-west comes after the angle. Okay, and another example, if we're traveling this direction, and this would be 45 degrees, and that would be 45 degrees east of the north bearing line, right? So remember, your north-south is your reference on your bearing. So north and south will always be listed first there, and then it's however many degrees east or west of the north or the south line is how you would write the bearing out. All right, so what about a problem here that we need to look at? Okay, so on this one it says a ship is 45 miles east and 30 miles south of a port. The captain wants to sail directly to the port. What bearing should he take? Okay, so if there's no picture, it's always helpful for us to draw one first. And so, first of all, it is, so here's the port, right? So the ship is 45 miles east, so east would be this direction, 45. And he is 30 miles south. South is this direction, 30 miles. All right, so here's where our ship is, right? All right, so he's 45 east and 30 south. What bearing should he take to go directly back to the port? Okay, so what are we trying to find here? We want to find the bearing. So if his port is here and the ship is here, right, then this is the line that he's got to take. Now, the first part of my bearing should be north, because this would be an acute angle so many degrees of the north. Like if this is the full north, south, east, west compass right here, okay, it's a north referenced bearing, right, not a south referenced bearing, because remember, it's got to be an acute angle, right? The acute angle makes with it. So it couldn't be a south bearing because that would be more than 90 degrees. It's not acute. Okay, so here is the reference angle for the bearing that I'm trying to look for. So I'm going to mark that as an X, right? Okay, so once we find that angle, then we can write out the bearing, all right? And we'll use our trig functions to do that. As a matter of fact, if this is my reference angle, I've got opposite and I've got adjacent, so I'll set it up with tangent. So this one will be tangent of the reference angle equals opposite over adjacent. And so okay, so now we can go and plug in. So it'll be tangent And my reference angle here is going to be x. It'll stay as an x. And so we've got the opposite, 45. And we've got the adjacent as 30. And so now we've got an equation that we can solve for x, and we'll have our angle. Remember, the x is wrapped up inside of the tangent function, so we know how to handle that. We've got to do inverse tangent to both sides. All right, so we're doing inverse tangent to both sides of my equation here. All right, and of course, inverse tangent of the tangent of x is just x, so we're good there. And then, so to finish this up, I'll have to go inverse tangent of 45 over 30. That's where we can pull up our calculator. And so we can go to the functions. We can get our inverse tangent of 45 over 30. And remember, make sure that you are in degrees. So I'm going to go up here to the settings and just change that back to degrees, and then we will come up with the right angle. So we'll round that off to 56.31. Okay. And so that's my angle. Now the question is, how do I complete this and write it as a bearing? All right, so in order to finish the bearing, remember, the reference direction of this bearing is going to be north. So the full answer would be north 56.31 west. So that's your full bearing. All right, so there you go. Okay, what about this next problem here? Okay, so on this one it says a ship leaves port at noon, okay, and it heads due west at 20 knots, or 20 nautical miles. Okay, so the good thing about this one is they've given us a drawing, okay, and so it leaves port at noon and heads west at 20 miles per hour, you could say. All right, so it's going this way. Now at 2 p.m., so notice that's 2 hours later. So how far would he have traveled total if he's going 20 miles an hour? 40. So from here to here, this distance is 40. He's going west for 40 miles, right? And then at 2 p.m., after he travels that 2 hours, goes 40 miles, he changes course to this bearing, north 54 degrees west. So I know that this angle right here is 54, and here's now the direction that he's traveling. Okay? Find the ship's bearing and distance, okay, from the port of departure at 3 p.m. Okay, so that's another hour, which means he will go another 20 miles this direction. All right, so again, the boat, here's the port. He's gone this way for 2 hours, 40 miles. Change direction to this bearing and goes 1 hour, which is another 20 miles. All right, and so we've got our directions here. We've got our drawing all laid out. And here's what it's asking for. Find the ship's bearing and distance from the port at 3 p.m. So where he's at right here, what is this bearing? What is this bearing? All right, so let's figure out exactly what we need to know here. Okay, and by the way, they're asking for two things, the bearing and the distance. Let's talk about the bearing first. Now, the bearing is going to be off north as a reference line, not south, because this is the angle that we need to try to find. Right? This is the angle that we need to try to find in our bearing. So the bearing is going to be north, this angle, west. All right? North, this angle, whatever it is, west. We got to find this angle somehow. Now, we've got a right triangle right here. Okay? So we'll be able to find this angle, and we'll talk about how to do that. Once we get this angle, let's subtract this angle from 90, and then we'll have the angle of the bearing that we need. All right, so hopefully that makes sense. Now the question is, let's now focus on trying to get this angle. Well, in order to get this angle, right, then I'm going to have at least 2 out of these 3 sides in order to set it up with a sine, cosine, and tangent. Okay, so I've got from here to here is 40. So if I can find D and I can find B, then I would have these 2 sides and I can find this angle with tangent. Okay, so that's going to be our task. We're going to try to find how long B is and how long D is, so we can have two sides of this right triangle so we can get this reference angle so we can finish our bearing. All right, so let's talk about how we're going to find B first. Well, the good thing about it is we've got right triangles within right triangles on this thing. So now if I just look at this right triangle with B, D, and this 20 right here, okay, then I can kind of use this triangle to find the B and the D that I need. Okay, so this full angle right here is 90. So if this is 54, this angle inside the triangle here would be 36. 90 minus 54, okay, is how we got that. Okay, so now if I'm setting it up to find B, it'll look like this. Okay, it'll be the sine of 36 equals B over 20, opposite over hypotenuse. Okay, so now in order to find the B part of this, and once again, just to make sure you're following me, opposite, B's the opposite, 20 is the hypotenuse, reference angle is 36. Opposite over hypotenuse, use sine. Okay, so to finish this, I'm going to multiply by 20. I'm going to multiply by 20. And so here, we're going to have B is equal to, we can put that directly into our calculator, and you would find that that's 11.7557. So that's 11.7557. Now I'm taking that out to 4 decimal places right now because we have a multi-step problem. And in a multi-step problem, you want to be very accurate until the end. Because if I just round it off to 1 or 2 decimal places right now, that would throw my answer off. Because again, I'm in a multi-step problem. You want to be accurate as possible and just round one time, and that's at the very end. All right, so now, how are we going to find, let's see, how are we going to find D now out of this? Well, I can set up D with cosine. I can go cosine of 36 is equal to D over 20. All right, cosine of 36 equals to D over 20. Using that same triangle and that same reference angle, right? Here's my reference angle, 36. This is the adjacent. 20 is the hypotenuse. Use cosine. I'll multiply both sides times 20. And then we've got D is equal to 11.1803. So you can plug that into the calculator. 20 times the cosine of 36. Make sure you're in degrees if you're using Desmos. And you should come up with this. Whoops, not 11, that's 16, sorry. All right, so that's 16. That's 16.1803 for D. Okay. Now, here's the deal. Okay, if I'm trying to find this angle so that I can get my bearing, then I need the opposite, which is this piece, but I need this whole thing. So I need to add 16.1803 to 40. So if I add those two together, this whole thing is 56.1803. So that would be the entire side, which is what I need. Okay? And now I can set it up. I have an angle that I'm looking for. I've got the opposite side. Now I'm looking at the big triangle, the big right triangle. I've got the opposite side. I've got the adjacent side. I can set it up with tangent. So tangent of x is equal to, tangent of x is equal to 11.7557 over 56.1803. All right. We can do the inverse tangent of both sides here. Inverse tangent of the tangent of x equals the inverse tangent of 11.7557 over 56.1803. All right. And so now we do the inverse tangent of both sides, and we'll get x is equal to 11.8186. All right. Now, remember, that's this angle. But for the bearing, I need this angle. So I've got to take this 11 and subtract it from 90. All right. So if we go 90 minus 11.8186, we'll get 78.1814, and then so now I can actually write out my bearing, which is going to be north, right? 78, now we can round, 0.18 west. So that would be the correct bearing. All right, so again, since this angle is 78.18, that's north, a bearing of north, and then 78.18 degrees west. So that's the correct bearing, right? So there's your bearing. That's only part of the answer, because what else did they ask me to find, if you notice? Okay. The other thing they asked me to find is the distance as well. All right. So I need to find this value of C, and so again, now that I have this angle, I can go ahead and find C, probably with sine if I wanted to. We can plug this in now with sine. So I can go sine of this angle right here, the angle X, which is 11.8186, is going to be equal to opposite, which is 11.7557. So that's 11.757 over the hypotenuse, which is what I'm looking for, and that is C. We'll leave it as C. And so to finish this now, I'm going to multiply both sides times C and get C times the sine of 11.8186 equals to 11.7557. And so now I'm ready to divide both sides by the sine of 11.8186 sine 11.8186. Now we've got a calculator that'll finish that up for us, and when you plug that in, you'll find that C is equal to 57.4. So that's how many miles now it is away from the port. All right, so those are the techniques that you will use now to finish the quiz that's waiting for you.